This video will explain the triangle congruence properties. Keep in mind that if you have a triangle, there are 6 parts. In triangle MRE, there's 3 angles, angle M, angle R, and angle E, and 3 sides, MR, RE, and EM. So 3 sides, 3 angles. Now if we have 2 triangles that are congruent, meaning they have the same shape and same size, then there are 6 pairs of corresponding parts that are also congruent. Here we have another triangle, PQS. If we're told the triangle MRE is congruent to triangle PQS, we can look at the 3 pairs of corresponding sides and the 3 pairs of corresponding angles. To know how to match them up, we can line the triangles up and orient them so we see the matched sides and angles, or we can look at the statement to figure it out. Now I have triangles MRE and PQS in the same orientation, so it's pretty easy to see which ones match. MR is congruent to PQ, RE is congruent to QS, and EM is congruent to SP. But the triangles are not always going to be oriented in the same direction. We can also look at the congruence statement to figure out how to match them. Let's do this with the angles. If angle M is the first angle in the first triangle, then we can look at the first angle in the second triangle to match it up in our congruence statement. Angle M would have to be congruent to angle P. Now I can do the same thing with the sides. MR, the first 2 letters, would have to be congruent to the first 2 letters in the next statement, and so on. If angle R is the second letter, then it's going to be congruent to the second letter in the congruent statement, which would be angle Q. And likewise, angle E, the last letter, is congruent to angle S. 3 pairs of sides and 3 pairs of angles. Now let's say I wanted to go backwards and prove the triangles were congruent. How many of these 6 corresponding parts would I actually need to know? Would you need to know that all 6 are congruent? Or maybe 5, 4, 3, or even just 2 of the parts? What is the minimum number? Well, let's look at it. We're going to start by using some pre-measured sides and angles. Here we have one side, this red segment, and one angle, this blue piece here. Now keep in mind, the side has to be a fixed length. The length of that segment cannot get bigger or smaller. The angle is defined by how the measure is. How many degrees? It's not a measure of how long the sides are. So those dashed segments can be as long or as short as we want. We just can't change the number of degrees in the angle. Now let's put these together and form a triangle. I'll move the segment over. Here's the triangle I get out of this. And let me move it out of the way. Is there anything I can do with this picture without changing the length of the red segment or the number of the degrees in the blue angle and get a different triangle? Sure, I can just rotate the red segment around and I'll get a different triangle. Let me draw it. And I'll move them side by side so we can compare. Are these triangles congruent? Well, they're certainly not the same shape, so we end up getting different triangles. This means no, we cannot guarantee congruence with just one pair of sides and one pair of angles. This does not work. So let's try another combination of 2 parts. Let's try 2 specific angles. Can we guarantee congruence? Well, let's line these up and put them together. Here's our first triangle. And let me move it out of the way. Is there anything I can do with this picture without changing the measures of angles 1 and 2 and get a different triangle? Well, if I spread them out a little bit and extend it, here's another triangle. And I'll move it over so we can compare. Are these triangles congruent? No. They might have the same shape, but they're certainly not the same size. So once again, knowing these 2 parts was not enough to guarantee congruence. So no, we can't prove congruence. Now let's try another combination of 2 parts. Let's take 2 specific sides, the blue segment and the red segment. Let's see if we can make a triangle. Well, if we connect them, and then draw in a 3rd side, here's our triangle. Let's move it out of the way. Is there anything I can do without changing the length of these 2 segments and get a different looking triangle? Sure, once again we can rotate it, draw on the new side, and we get a different looking triangle. Let's compare. Are they congruent? Meaning, do they have the same size and same shape? And the answer is certainly no. So once again, 2 parts was not enough to prove congruence. So it would seem that we're ready to make the conclusion that given only 2 congruent parts, it does not guarantee congruence. So once again, 2 parts does not guarantee congruence. So let's try 3 parts. Let's try 3 specific angles. Angles 1, 2, and 3. Let's orient them and put them together. If we extend the length of the sides, we would form a triangle, and here's our first triangle. Let's move it out of the way. Is there anything I could do to this diagram without changing the measure of the angles and get a different looking triangle? Sure, I could just move the angles either closer or further apart. Let's go further apart, for instance. And we'll move angle 3 up a little bit. Connect. And we can see that these triangles are certainly not going to be congruent. Now, if we look carefully, we may notice that their shape appears to be very much the same. They are what we call similar, same shape, but they're not congruent because one triangle is certainly a lot bigger than the other. So once again, angle, angle, angle here, 3 angles, has not guaranteed congruence. Well, let's try another combination of 3 parts. Let's look at 3 specific sides. Let's connect these and see if we can form a triangle. I'll move my green segment over. I'll move my blue segment so the vertices touch, and then move that 3rd segment around. And I form a triangle. Let's move that triangle out of the way. Now, is there anything I can do without changing the length of these segments and get a different looking triangle? Now, it's tempting to say, well, let's just move the segment around, rotate it, and then move the other segment to touch. The problem is, if we move the green segment down, the red segment's no longer long enough to touch. That means there's no other way to do it because they only fit in one exact way. We finally found a combination that works. 3 pairs of sides is enough to guarantee congruence. So this is the first box that we can check yes. 3 congruent sides will guarantee congruence. So that means we need to know at least 3 parts to guarantee congruence. Now, not all combinations of 3 are going to work, so let's look at which ones do. All right, these are our triangle congruence properties. I'm going to have a set a table here, and if you don't have enough time to copy as we go along, just pause the video at the end, copy it down, and then resume it. So let's go through the 4 combinations that work. The first one is referred to as SSS, or side-side-side congruence. This means we're going to have all 3 pairs of corresponding sides congruent. In the picture, it'll look like this. One pair of sides will have 1 tick mark, another pair of sides will have 2 tick marks, and another pair of sides, the 3rd pair, will have 3 ticks. The 1 and the 1 go together, the 2 and the 2, and the 3 and the 3. The second combination is referred to as SAS, or side-angle-side congruence. In side-angle-side congruence, we have a pair of sides, and notice that the letter A is in between the S's, meaning the angle is in between the sides. Here's the picture of that. Now notice in the picture, the 2 sides with the tick marks, where they come together is the angle. The angle that we know has to be in between the sides in order to have side-angle-side congruence. The 4th combination is known as ASA, angle-side-angle. Here, in angle-side-angle, we have 2 pairs of angles, and the S is in between. That means in between the 2 angles is the side that's also congruent. Let's look at a picture. Here we can see the 2 angles marked off with the arcs, and the side is in between those angles. Or, another way to think about it is the angles are on the ends of that side. This is ASA congruence. Now the last combination that we're going to look that works in this video is referred to as AAS. In angle-angle-side congruence, we have the same parts, except the side is somewhere else. Notice that the S is not in between the A's, which means the side is not in between the angles. So an angle-angle-side congruence means 2 pairs of corresponding angles and a side not between them. Here's the picture. Notice we still have 2 pairs of angles marked off, but the side where the tick is not in between the angles. It's somewhere else. So these are the 4 that work. If you didn't finish copying them down, just pause the video, copy, and then resume when you're ready. Let's move on. Now you may notice that some combinations work and some don't. Well, here's a little saying to help you memorize this. The combinations that don't work can be remembered with just one thing. No, I'm not cussing at you. It just means this. Don't be an ass at AAA. This is how we memorize the little saying. Alright, if you remember this symbol, angle, side, side, and angle, 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 these are the 2 combinations that don't work. Now, in order to keep things PG rated, we're going to, instead of saying angle side side, we're going to write that as SSA. From here on out, that will be referred to as SSA instead of angle side side. All right, let's look at some examples here. I have 3 pairs of triangles, and we're going to prove whether they are or are not congruent. In order to do this, we're going to list out what parts we're going to do. All right, so let's look. In the first set, I see that we have 3 sides marked off, the 1 tick, 2 tick, and 3 tick. Let's list out what they are. I see that we have side AC, which has 1 tick, and the other figure would be congruent to side RP, which also has 1 tick. Side AB has 3 ticks, which means it's going to be congruent to side PQ, which also has 3 ticks. Side BC, the third side of that first triangle, would be congruent to side PQ because they have 2 ticks. Now these are side, 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 which is a way to prove congruence. Therefore, triangle ABC is going to be congruent to triangle PQR. I know my order is correct because if we go from side A to B to C, that's the 3 tick marks, 2 tick marks, and back through the 1 tick mark, which on triangle PQR would be 3, 2, 1. We want to make sure the order matches, and we know that these are congruent by side, side, side. Now in figure B, I see 3 things. I see some angles, but instead of having arc measures, they actually put the actual degrees. We have a pair of 52-degree angles, a pair of 40-degree angles, and we have 1 pair of sides that have the 1 tick. Let's list these out. Angles S and N are congruent because those are my 52-degree angles. Side SE and NU have the 1 tick, and angle E and angle U are both 40-degree angles. Are these congruent? Yes, they are, because this is angle side angle. 2 pairs of corresponding angles and the side in between. So triangle YES is congruent to triangle FUN by angle side angle. The third combination. I see 3 things. I have a pair of angles that are 36 degrees and 2 pairs of sides. Let's list these out. Angles E and M are congruent. Sides EF and MO both have 1 tick, and sides FD and ON are congruent. But be careful, these triangles cannot be guaranteed congruence, because this is side-side angle. The angle is not in between, which means this is one of the properties that says we cannot guarantee congruence. So here, side-side angle does not guarantee congruence. So to keep in mind, we need a minimum of 3 parts to guarantee congruence, and it has to be one of these 4 combinations right now that work. Side, 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 angle, or angle, angle, side. The 2 that don't work are these ones. Now here I've got 6 problems that I want you to work out. You don't need to list all the parts, just tell me, can you guarantee congruence, and by what property? Pause the video, work these ones out, and then resume it when you're ready to check. I'll give you a moment. Problem number 1 cannot guarantee congruence because we only have 2 parts, and we need a minimum of 3 to guarantee congruence. For number 2, these ones can be guaranteed congruence because that side is angle side. The angle's in between the sides. For number 3, we have 2 sides, but this time the angle is not in between. That would be side-side angle, which doesn't guarantee congruence. For number 4, I see 3 pairs of corresponding sides, so yes, those are guaranteed congruent by side, side, side. On number 5, the angles inside this time are marked. We have 2 pairs of those that are corresponding and congruent, and 1 pair of sides. So this, is it angle, angle, side, or angle, side, angle? Take a look again. The side is not in between, which means these are congruent, but it's angle, angle, side. It's the last one that has the side in between the 2 pairs of angles. So the last one is also guaranteed congruent, but now it's angle, side, angle. Take a look at those last 2 problems and notice the difference. The difference between angle, angle, side and ASA is where that one side is. If it's in between, it's ASA. If it's not in between, then it's angle, angle, side. All right, thank you for watching, and hopefully it helps.